Hey guys, this is CHEMPLIFIED and today we will talk about alkanes. So let's begin with the simple definition of alkanes. Alkanes are the simplest organic compounds made up of carbon and hydrogen only. So alkanes are only made up of carbon and hydrogen. We are talking about just alkanes. So alkanes are only made up of carbon and hydrogen atoms. Examples are methane, ethane and propane. If you look at the structure and the formula, you will find that only carbon and hydrogen are used in different numbers or in certain ratios. You can say like that. Alright, so alkanes are the simplest organic compounds made up from carbon and hydrogen only. Now, what is the general formula? The general formula for alkanes is CnH2n plus 2, where n is 1, 2, 3, and you can continue it with 4, 5, 6. You can take the chain as long as you can. If the compound is alkane, it will follow this formula. Let's check it. Put n is equal to 1, C1H2 into 1 plus 2. You will get CH4. The first member, this is methane, right? Now use 2, C2H2 into 2 plus 2. You will get C2H6. This is ethane, the second member, and just like that you can go as long as you want. Let's take 10, C10. H will be 2 into 10 plus 2. What you will get is C10H22, right? That's how the formula works. So if any compound is alkane, it will definitely follow this particular general formula. Alright, now let's talk about the structure. To understand the structure, we will consider two examples, methane and ethane. That is, to understand the orbital makeup of the compounds, alkanes. What do you mean by orbital makeups? How the orbitals of carbon are arranged in space so as to form the molecules, right? Now before we go for the structures, you should know about the definition of hybridization. We will discuss this topic really soon in separate videos, but for now just understand, in alkanes carbon uses sp3 hybrid orbitals. Remember, sp3, in alkanes carbon uses sp3 hybrid orbitals to form bonds with hydrogen atoms. So the bond between carbon and hydrogen is between the sp3 orbitals of carbon, right? Let us look at the structure. Now this is the example of methane. We have taken methane, right? Let me change the color. We have taken methane. 1 second. We have taken methane, right? Now the carbon is sp3 hybridized. What is the meaning of sp3 hybridized? Let me talk about it a little bit. Now carbon has 2s and 2p orbital, right? Now hybridization definition is hybridization is intermixing of orbitals to give a new set of orbitals of equivalent energy, right? Now these are the two orbitals. These orbitals mix with each other to give sp3. Why there is only one s? Because there is one s orbital used in sp3 hybridization, and there are 3 p orbitals which are used in sp3 hybridization. Now if you look at individual orbital, now s orbital is spherical in shape. Now this is px, py and pz, right? Let me make the structure X, Y and Z. Now Px is like this, Py is like this and Pz is like this. They all are perpendicular to each other in reality, right? So when the molecule is formed, you should find that all these should be perpendicular to each other. The angle should be 90. The hydrogen combined with carbon should be at angle 90 degree. But in reality, this is not the case. Why? Because when you see the structure, you will find that the structure of methane is tetrahedral. So there is some change in the structure of orbitals. So that change is hybridization. Due to hybridization, carbon now has sp3 hybridization. All the four orbitals are at equal angle from one another, are of equivalent energy, and they form single bond with hydrogen, right? This bond is sigma bond. All the four bonds are sigma bonds. Sigma bond is found between carbon and hydrogen. One electron from hydrogen is shared with one electron of carbon. So there are two electrons shared, completing the octet of carbon as well as of hydrogen. Now remember, the structure is tetrahedral and the angle is 109 degrees and 28 minutes. Now all the angles, you can take any two bonds. This angle is also 109, this angle is also 109, this angle is also 109 degrees 28 minutes. This is the use of hybridization, right? Due to hybridization, all the angles are equal in case of methane. Similarly, let's take a look at the structure of ethane. This is the structure of ethane, C2H6, right? One second. This is the structure of ethane. Now, if you look closely, you will find the hybridization of carbon is still sp3. Hybridization is still sp3. Both the carbons have sp3 hybridization. Now, each carbon is connected with 3 hydrogen atoms by sigma bond. The sigma bond formed is between s orbital of hydrogen and sp3 hybrid orbital of carbon. Remember this. And the last bond, the fourth bond, is formed between 2 carbon atoms. This bond is between the sp3 hybrid orbital of one carbon and sp3 hybrid orbital of other carbon, and the bond is sigma bond, right? That's how the structure works. Now in this two-dimensional structure, you must see that this is 90 degree, but in reality this is not 90 degree. The structure is still tetrahedral. All right, so if you look it in three-dimensional space, you will find that this angle is also 109 degrees and 28 minutes. All right, that's how the structure works. So all the angles are equal in ethane. Remember that. The only difference that you will find in ethane and methane is the bond length. In this case, the hydrogen and carbon bond length is 1.09 angstroms and carbon-carbon bond length is 1.54. So this is smaller, this is a bit larger than carbon-hydrogen bond. This is the only difference. So the bond length is different with carbon and with hydrogen. That's it. This is the structure. Now, alkanes follow chain isomerism. Alkanes follow chain isomerism. The first three hydrocarbons of alkane series, that is methane, ethane and propane, do not exhibit chain isomerism. They do not show chain isomerism. But the fourth member is butane. Butane exists in two isomeric forms. There are two isomeric forms of butane. What are those isomeric forms? These are the two isomeric forms. First one is N-butane and second one is isobutane. These are the two isomeric forms. So the first member of alkane series that shows isomerism is butane. Butane is the first member that shows chain isomerism. All right. Now let's take another example. This is pentane C5 H12. The isomeric forms of C5 H12 are given below. What are the names? First one is N-pentane. Second one is neopentane. Third one is isopentane. These are the three isomeric forms of pentane. The IUPAC name will be 2,2-dimethyl. 2,2-dimethyl propane. Right? You can also write it as like this. Now, why these are isomers? Because they have the same formula. The formula is C5H12 in all these cases. In all the three cases, the formula is C5H12. But the structures are different. And because the structures are different, the physical properties are also slight different from each other. That's why we are studying isomeric forms. We will discuss about alkane a little bit more in the upcoming videos. So till this will be it for today's video. Thank you very much.